We are now recording, okay? So this is, okay, these are called piecewise functions. Have you seen these types of functions before? You saw them when it said find the value of f of x. We saw some piecewise functions, and we kind of called them out of that, but now we're going to look at them in a little more detail, and we're going to graph them and stuff like that. So some function are in pieces. They are called piecewise functions. Okay? One of the most famous, okay, it's been on all the celebrity shows and everything. One of the most famous piecewise functions is the absolute value function. Okay? Does anyone know what an absolute value function looks like? No. Okay? So what a piecewise function is, it breaks a function into two pieces. Like this says, for f of x, so the absolute value function, you can break it into two pieces, where one part is y equals x if x is greater than 0, and y equals negative x if x is less than 0. Does anyone know what y equals x looks like? What's the y-intercept for y equals x? 0, right? What's the slope for y equals x? What's the slope of this line? If I were to graph y equals x, what's the slope? Y equals x. The slope is 1, not 0, 1, right? And it has a y-intercept of 0. So what this says is, for if x is bigger than or equal to 0, I use this function y equals x. And then it says if x is less than 0, I use this function y equals negative x. Okay? Y equals negative x. Y equals x is a line with a slope of 1. So if I were to go up this way, that's 1/2 of my piecewise function. Okay? What does the other half of that piecewise function look like? What does y equals negative x look like? Will, could you close your computer, please, and look up here and pay attention? Yes, Jessica? Yeah, because the other half, it goes down from left to right, and so it goes kind of up this way, okay? And that is the graph of this piecewise function, which is y equals x if x is greater than or equal to 0, y equals negative x if x is less than or equal to 0. Also known as y equals the absolute value of x. So if you were to plug this into a graphing calculator, y equals x looks like this, you would get this graph. Have any of you ever graphed absolute value functions before? Look at it. If I plug in negative 3 in here, what number do I get out? 3, right? So if I plug in negative 3, I get out 3, right? What if I plug in positive 2 in here? What if I plug in 2 in there? What do I get out? 2, right? And there's that point, 2, 2. So those are a couple points on that graph, okay? Are you filling this in? Writing it down? Doing it as we go? Okay, so let's look at the next one. Whoops, I can't look at the next one because it's over there. So let's look at this one. I'm going to grab it and make it bigger. Okay, partial. Isn't the Mobi technology amazing? What will they think of next? All right. I don't know. So in any case, this piecewise function, f of x, is like what? Whoops. It says y equals 3 if x is less than 5. And it says y equals x plus 2 if x is greater than or equal to 5. Okay? So the way you do it, you go to first, if x is less than 5, what does the line y equals 3 look like? What does the line y equals 3 look like? Yes? What are you doing there? It's horizontal. How high is it? 3 high. It's 3 high. Okay. It's 3 on the y-axis. Very good, Katira. So what you do, you go up here to the starting point, which is 5, and I'm going to put an open circle there. And the reason I'm putting an open circle there is because anything less than 5, I use the graph y equals 3. So I'm going to start here at that point, and I'm going to go to the left, going that direction like that. You understand what I'm doing? Okay? Then it says if x is bigger than or equal to 5, I use the graph y equals x plus 2. Okay? So the way you figure out where this graph starts is by plugging in the transition point, which is this point right here. If I plug in 5 into this equation, what do I get out? 7. Okay? So at 5, the value of this graph is 7, and I put a closed circle there. Yes, ma'am?
Can we also use curly brackets or square brackets?
Can you also use curvy brackets and square brackets?
Yeah, like on the number line.
No, because this isn't a number line. This is in 2 dimensions, okay? So it's not like a number line graph. Yeah, don't do it, because now we're going to use open circles and closed circles, okay? And so at y equals 5, the value of this function is 7. And what does the line y equals x plus 2 look like? What's its slope? What's its slope? 1, right? So from this point, I'm going to go up 1 and over 1. And so from this point, this graph looks something like this, okay? And that's what that particular piecewise function looks like, okay? So you graph it in 2 parts. You see what it's doing at the transition point? If it's less than, you put an open circle. If it's greater than or equal to, you put a closed circle. And then you graph the line that way and you graph the line below. Follow that? Okay? We'll do another example, couple more examples until we get the hang of it. Okay? So next one. Graph 2. Okay? Here it is. So I'm going to start at the transition point, -3. So I'm going to plug in -3 into the top function. What do I get out if I plug in -3 into this top function? -5, right? So you have a point, and since it's less than, do I put an open circle or a closed circle at that point? Open circle, closed circle, yeah. Open, very good, okay? So at -3, -5, did I do that right? No, that's -3, -5. So I put an open circle like that, okay? Now this line has a slope of 2, but I have to go less than 3. So I'm not going to go this direction, I'm going to go this direction. So it has a slope of 2, which means every 2 I go up, I go over 1. So I could go backwards 1 and down 2, right? That would be the same thing. Backwards 1 and down 2. And draw a line going this way from this point. Follow what I just did? Okay? That's a line y equals, so I use the line y equals 2x plus 1 where x is less than or equal to 3. Y equals -x if x is greater than or equal to -3. So what I'm going to do, I'm going to plug in the point -3 into this equation. What do I get out if I plug in -3 in there? +3. So at -3, I have a +3. Is that an open circle or a closed circle? Closed circle. So I go up to -3, +3. I put a closed circle there. And what is the slope of this line? What is the slope of y equals -x? What's the slope? Gia, what's the slope? -1. So that means from this point, I'm going to go down 1 over 1, down 1 over 1, down 1 over 1. And so that one kind of looks like this after that point. So those are called piecewise functions. Okay? They're really important when you get to algebra 2, when you get to pre-calculus, and especially when you get to calculus, if you get there, okay? You will eventually, probably, but they come up a lot. Yes, sir?
Where do you get the 5?
Where did I get the -5 here? I plugged into the first equation, so I take these 2 points and I plug them into both parts, okay? So when I plug in -3, I get out -5, right? I put 2 times -3 is -6, plus 1 gives you -5. See that? Okay? And then I take the other endpoint of this one, okay? And I do that. Okay? Should I move on? I want to move on. The rest isn't too bad. Oh, we have to graph these things? Oh my goodness. These are hard. Okay? I'm just going to do this one, and then I'm going to jump down here because we're going to run out of time otherwise. X is less than 0. Okay? -4. So what does that look like? What is y equals, for x, what does y equals -4 look like? Yes, Jessica?
The horizontal line from
-4. So at 0, what's the value going to be? -4, except I put an open circle there, and then I go to the left, okay, going this way, right? And then I'm going to plug in the point 0 in here. What do I get if I plug in 0 into this bottom function? 1, right? So I'm going to go to the point 0, put a +1, and that's a closed-in circle, right? Closed-in circle. What's the slope of this line? Y equals 3x plus 1. What's the slope? 3. So from that point, I'm going to go up 1, 2, 3, and over 1, and I'm going to draw a line that goes like this. Okay? Why would you ever use a piecewise function? Because they're in math books and people from math like. But there are actual piecewise functions in real life. For instance, you ever go to the parking garage, like in Denver and Boulder, or they don't have many parking garages in Louisville, but you know where they say like charge you $2 for the first hour, and at 3 hours it jumps up to $3 and so on and so forth. At 4 hours it jumps up. So that would be a piecewise function that looks kind of like this and have jumps. It would kind of go like this for each. So maybe this is 1 to 2 hours, you get charged a certain rate. Then 3 to 4 hours you get, or 2 to 3 hours you get charged another rate. Same thing with like utility bills or your water bill. You know, you water grass, right? If you water your grass, it kind of goes up. The costs aren't very high if you use so many gallons, but then after you get to a certain, if you use so many gallons, then they start charging you more per gallon. So then your piecewise function might jump like this. And if you're a real water waster, then it starts going up really steep after that point. You don't read the utility bills, but that's what happens with gas, with water, with parking garages, all that. But there are real life applications of it. Okay? So I got time to finish these, okay? And your homework is pretty short, so I can finish this. So in this one, let's just do this number 4 example, and then we'll kind of go backwards, okay? So with this one, this is broken into 3 pieces instead of just 2. So it says if x is less than or equal to -4. So how do I start? Who can tell me how to start that? What should I do first? Other than Jessica. Yes, Meadow. Good. Put the -4 into here. Okay? When I put -4 into there, I get out, what do I get out? -4 makes +4 minus 5 gives you what? -1. So I have a point -4, -1. Is that a shaded circle or an open circle? Shaded because it's less than or equal to. Okay? So at -4, -1, I put a solid line. And then this says, don't worry too much about the y-intercept. All you really have to worry about is the slope. What does the slope of -1 look like? Got a slope of -1. So remember, I want a slope of -1, but I don't want to go down this way. So I'm going to go this way instead. See that? Okay? So I'm going to take my slope of -1, and I'm going to kind of go up this way, because this would be a slope of -1, down 1 over 1, down 1 over 1. After that, between -4 and 1, it's the line y equals 0. What does the line y equals 0 look like? What does the line y equal 2 look like? Go ahead, Jessica.
Straight horizontal line.
Where?
0.
At the x-axis, okay? So y equals 0 from -4 to 1. I have open circles on both of those, okay? I go along the x-axis from -4 until you get to 1. I have open circles, okay? And I take off my arrows, okay? And so from here to here, it goes like that. See that? Okay? After 1, it uses this graph, okay? So first thing I would do is plug in this 1 into here. What do I get out if I plug in a 1 into here? 1/2 minus 3. What's 1/2 minus 3? -2.5. So at 1, I have the point -2.5, and that's a solid circle, and it has a slope of 1/2 over 2 up 1. So something that looks like this. Whoops, but it's got arrows on it, okay? As it goes out there. So that's what that piecewise function looks like. 3 different pieces, okay? Tricky? Okay then, so now we're going to kind of go backwards, okay? They want you to, in the backward section, they want you to, for the graph, write the function using piecewise notation. So what you do is you'd say f of x equals something for x is greater than or equal to. So I'm going to call this, I'm going to say that this is a solid point. It doesn't matter which one you call greater than or equal to, or which one you call less than or equal to, because they overlap. Okay? So let's first figure out this one. What's the equation of this line? What's the equation of that line? Hayden? Y equals 3. So what I'm going to do is 3 for x is, oh, they say if, right? They say if. I'll keep it consistent, okay? 3, if x is greater than or equal to 2. Now I got to find the equation of this line, okay? Well, you could kind of look at the graph. What's the y-intercept? What's the y-intercept here? Hello? 1. What appears to be the slope? 1, right? So you're going over 2 up 2, that's a slope of 1. So I could write this equation, okay? Y equals x plus 1 if x is what? Less than 2. You understand that? Yeah? Okay? And that makes sense, because if I plugged in 2 in here, I'd also get out 3, so they overlap. Now I could have called this less than or equal to and this greater than, because you can't really tell which dot is shaded and which is open. Okay? And the last thing you want to do is evaluate. Okay? So in this, you don't have to look at a graph or anything like that. You just plug in the numbers. So -3, it says use this function if x is less than 0. Use this function if x is greater than or equal to 0. So which function do I plug in -3 in? And some of you had trouble with this on the quiz that we had. Other than Jessica, which function do I plug in -3 into? Jacob Berger? Right, I plug this into here because x is less than 0. So I'd get, what would that be, -18 minus 1, -19, right? Which function do I plug in f of 0 into? Top one or the bottom one? the bottom one, because it says greater than or equal to 0, I use this one. So I'm going to take 0 and plug it into here, which gives me out 3. Or, what do I get out? What do I get out of, which one do I use? Top or bottom? Bottom, and I get out 31, I think, right? 7 times 4 plus 3, right? F of -1, which function do I use? Top or bottom? Top, and then what do I get out? -7, right? 10, what do I get out? 73. 0.5, 6.5, you got it, right? Not too bad, right? Okay, so that's your notes. I have a worksheet for you for homework, okay? And it's just two graphing, two finding the equations, and then plugging in 4 values. Piece of text, right? No math Excel. If you didn't do the homework that's due today, I'll let you turn that in for 2 points less. Okay? If you ever had an absence, you could turn in without, excuse that. And that's the last thing in this chapter. Tomorrow will be reviewed, last day will be reviewed. I'll try to find a caboose that we can interact with. I even tried that in my pre-cup last night. That's your homework, that's it. All you gotta do. Oh, just in time. Just time. Oh, I have to stop my recorder. How long did I talk for?
A lot.
20.